This is a scimitar, 40,000 pounds of lethal weapon to get into the air. On land, it would need half a mile of runway at least. Same engines, different aircraft. A Sea Vixen landing at 130 knots, 720 feet of flight deck, and there's room to park. With the steam catapult, the aircraft is airborne from standstill in 150 feet. And the arrestor gear brings it back to a standstill again in about 220 feet. Modern aircraft are fast and they're heavy. They couldn't operate at sea without the equipment and ideas developed over the years of Fleet Air Arm operations. Like the angled deck, for instance. Once upon a time, landing was a bit of a hazard. The straight-decked carrier was headed into wind, and before an aircraft landed, barriers were erected in case he missed a wire to protect the aircraft parked forward. After the landing, the barriers were lowered and the aircraft taxied over them into the park. With the angled deck, no barriers are needed. The landing area is offset several degrees to port, and the ship steers so as to bring the wind down the angle. With a clear run and nothing in the way, an aircraft can land like this, or do a bolter like this. No danger to the deck park or the pilot. The right equipment needs the right men to use it. Men who know what to do and when to do it. Every time an aircraft lands on or is launched, the flight deck team hold in their hands a pilot's life and the safety of a very expensive piece of aeroplane. They're a team. They must work like one. A clear drill, laid down, learnt, absorbed into their systems. Launching and recovery rates are high if the drill is smooth. A new flying day. On the compass platform, the captain discusses the day's program with Commander Air, responsible for all air operations.
Well, will you be satisfied with that?
Yes, sir, I will. If I launch the 1030 serial at about 10:45, serial 3 will easily get off at 11:30. Would that be all right, sir?
That'll be all right by me, yes.
I'll go and tell Little F, sir.
Good. Thanks very much.
Bill, I've just been talking to the captain about the program. I'm afraid we'll have to delay the 10:30 serial by half an hour.
Yes, sir.
But we should only need to delay the following one by 15 minutes. We must catch up as soon as we can.
All right, sir. Yes, I'll tell ACR.
Thank you.
From Flyco, Little F, real title Lieutenant Commander Flying, controls all aircraft movements on the flight deck and near the ship. Working under his direction is the aircraft control room. Here, the spotting of aircraft below and on deck is planned to get the right aircraft to the right place at the right time. On the flight deck, they're handed over to the flight deck officer. In charge of all flight deck machinery is the flight deck engineer officer, who keeps Little F informed of its serviceability. He, too, must be briefed.
We'll use both catapults for this first serial, then concentrate on the starboard one for the remaining serials today until night flying.
How about the end speeds and weights? On time today, none of this 2 minutes notice business.
Well, here you are, right on time. If you've nothing better to do than bitch about getting your weight, you can go back down to your hole in the deck.
In turn, the FDEO briefs his arrestor gear EO and his catapult EO. Let's see how a steam catapult works. Beneath each catapult track are 2 cylinders, but we'll deal with just one for the moment. Inside is a piston assembly. The main piston is at the after end. And these are guide slippers to keep the piston aligned. The cylinder is connected to a high-pressure steam receiver through a launch valve. When the launch valve is opened, steam pressure drives the piston forward. The other piston is exactly the same, driven from its own receiver. Along the top of each cylinder is a slot, through which the 2 piston assemblies are connected to a shuttle. Around the shuttle goes the bridle, which is then connected to the aircraft. Open the launch valve, away it goes. The question is, why doesn't the steam escape from the slot in the cylinder? Well, here's why. Over the slot goes a cylinder cover, leaving a small opening through which the driving key drives the shuttle. This opening is now the only place where the steam can escape. To seal it, there's a steel strip running the length of the cylinder. Watch the action as the piston moves down the cylinder. The driving key lifts the sealing strip so that it can pass underneath. Following the driving key comes the driving iron, which pushes the strip back, so that when the main piston arrives, the cylinder is completely sealed against the pressure behind it. The main piston fills the main cylinder. A sealing block fills the cylinder cover, and the sealing strip is held in its seating by the pressure of the steam itself. On the forward end of the piston assembly is a ram. At the end of the piston stroke, this ram enters a cylinder filled with water, and the high pressure built up brings it to rest. Like this. To get the shuttle back to the after end, the grab is sent up after it. It latches on automatically and is moved hydraulically by the jigger below the flight deck. While the catapult is being warmed through, all the aircraft in the range are fitted with their holdbacks. The jaws are held together with rings that will fracture at a preset load as the aircraft is launched. The bag is to stop pieces of the rings from flying around when they break. During the warming through, all the catapult machinery is tested before any aircraft come near it. First, the loading chocks. Positioner rollers can move the aircraft athwartships to get it into position. The number of rollers driven varies according to the type of aircraft. The jet blast deflector can't be raised until the locking pin is out. The holdback loader is movable and must be set in the right position for the first type of aircraft. Then it's locked. The catapult is finally fired from the howdah at the deck edge, where the chocks, rollers, and jet blast deflector are controlled. But most other movements of the shuttle and jigger are controlled from the console below. The operator is ready to bring the shuttle aft for a light shot. Control round to retract, and the grab moves aft, bringing the shuttle with it. The console operator can't see what the grab is doing, so he has an indicator. When the grab is aft, he goes round to stand by. When all interlocks are made, he gives first ready. The howdah operator raises the JBD. The catapult EO gives the signals for the light shot, using the ready lights at the deck edge. The first ready is on the left. The right-hand light shows that the JBD is up and locked. Second ready comes from the howdah and is repeated only in the console. Control round to cocked. Final ready from the console. Repeated in the howdah and at the deck edge. Fire. The JBD is set to fall automatically. The control handle, which was locked by final ready, can now be moved to exhaust. This sets the jigger moving to send the grab forward. The full cycle of the catapult has now been proved, and the shuttle is maneuvered forward until flying starts. The launching drill is in 4 stages. Stage 1, the aircraft is directed onto the catapult. Stage 2, it's positioned by the roller mat, and the bridle and holdback are fitted. Stage 3 is the tensioning. Slack in the bridle and holdback is taken up, and the aircraft is pulled into its takeoff attitude. Here, the pilot gets the cockpit check. Fourth stage, the engines are run up and the catapult fired. Now let's see a complete launch in practice. First aircraft, a scimitar. The howdah operator has started the positional rollers. When the nose wheel has passed over the chocks, he raises them. The JBD rises. With the aircraft centered, the rollers are stopped, and the holdback is fitted. Ship's course and wind speed stabilized. Captain's permission to fly. A green light from Flyco. The signal to retract comes from number 1 of the crew.
Retract.
When the console operator sees that the shuttle is aft, he goes to stand by and checks the steam pressure. Interlocks all made. First ready. Down chocks from number 1. Brakes off. Tension. When number 1 is satisfied, he clears the crew away and hands over to the flight deck officer. The pilot is given the checkboard. First ready on, JBD up and locked, Flyco light still green. That's the signal for second ready from the howdah. The console operator gives a final check to his steam pressure, then cocked and final ready. Pilots ready. Flyco green, check the track, ready lights on, fire. The JBD falls, the holdback is recovered, and the control is put to exhaust. This closes the launch valve, opens the exhaust valve, and sends the grab forward. The steam receivers are being charged up for the next launch, and to complete a full cycle, the grab is retracted, ready for the next aircraft. Number 1 is waiting for a first ready before he can give down chocks. The pilot is happy. Wait a minute, no he isn't. Cancel in the howdah and the console. The shuttle is maneuvered aft until the bridle drops off. The engines have been left at takeoff setting in case anything goes wrong. Now it's safe to throttle back. Then the FDO waves in the offloading crew. The aircraft is pushed back abaft the chocks to slacken the holdback. While an air engineer checks with the pilot, the old holdback rings, strained by tensioning, are thrown away and new ones fitted. Meanwhile, the console operator has gone back to stand by and given first ready. Whatever the trouble was, it seems to have been sorted out on the spot. So the scimitar can be reloaded and launched. last launch of the serial coming up, a Sea Vixen. Quickly, some changes have to be made for the different aircraft type.
Vixen 245, steam pressure 310.
A reduced tensioning pressure, and a change in the number of driven rollers. A Vixen bridle is brought up ready, and the holdback is repositioned. Now the Vixen can be loaded. It's the last one off, so
This is the last one of the serial coming up. It'll be a half-cycle shot.
the control goes to exhaust, then a change of drill. Round to half cycle. This puts the grab forward and leaves it there until the next launch. The heating steam valve is opened up to keep the catapult warm until it's needed again. The hydraulic supply to the chocks is shut off and the holdback anchor block is removed. The locking pin is replaced in the JBD, leaving a clear deck for the recovery. While things are relatively quiet, let's take a look at the arrestor gear. Connected to each arrestor wire is a cylinder containing a ram. There's a set of sheaves on the end of each, and the arrestor wire is led down from the deck and rove round these sheaves. So, as the wire is pulled out, the ram is forced into the cylinder. The cylinder is filled with fluid, and it's connected to a piston-type accumulator through a control valve. Backing up the accumulator piston is a vessel of compressed air at 650 pounds per square inch. When the wire is pulled out, forcing the ram into the cylinder, fluid flows through the control valve and a non-return valve into the accumulator. The non-return valve stops the accumulator pressure, forcing the ram back until the time comes to reset. To reset the wire, there is a fluid pipe bypassing the non-return valve. The reset valve is in this pipe. When it's opened, air pressure forces the fluid back into the main cylinder, pushing the ram out and resetting the wire. The control valve is a key part of the arrestor gear. The aircraft's landing momentum is absorbed as it forces the fluid through this valve. Fluid flows into the valve from the cylinder and out to the accumulator. Between the inlet and the outlet is a barrel cut with tapering grooves and splines. On its way through the valve, fluid has to flow between the splines opposite the inlet. But as the wire is pulled out, the barrel is telemotored across. The narrowing of the grooves increases the resistance to the fluid flow and finally stops the aircraft. The barrel moves back when the wire resets. The splines cut on the barrel are of differing widths to offer greater or smaller resistance build-up to the fluid flow according to the weight of the aircraft. Indexing the spline valve to suit different types of aircraft is a vital part of the arrestor gear drill.
Recovery stations, stand by to receive 2 Vixens.
The arrestor gear settings for the type of aircraft are transmitted from Flyco to all control positions. In the main control room below, they're acknowledged by the watchkeeper, who then sets them up. The same thing happens in the forward unit control position. The watchkeeper here acknowledges the setting back to the main position, then makes his ready switch. When the main watchkeeper is satisfied with his own and the other unit settings, he makes his gear safe switch. Some further checks. accumulator pressure, air pressure, lift at flight deck level and the keeps in action. All checked. He makes the master ready switch, which brings on the safe to land light in FlyCo. The mirror control officer checks the pilot's approach and can wave him off if necessary. But little F has overriding control and can fire a red very light as a last-minute negative.
Wheels down, flaps down, hook down.
Gear serviceable, sub.
As the Vixen picks up the wire, this registers in the main control room. So, off goes the master ready switch, bringing on the unsafe to land light in FlyCo and at the mirror. When the wires reset, the indicator returns to normal and the master ready switch can be made again. Ready for the next aircraft.
Stand by to receive 3 gallons.
Different aircraft type, different settings. Acknowledged at the main control and the forward unit control. And when they're all ready,
Stand by to receive 6 scimitars.
the wire is inspected immediately after each landing. If it shows signs of wear, like this, up goes the red flag. There's no time to change it just now, but it mustn't be used again. With the faulty wire out of the way and the unit isolated, it's safe to land again. Later, when time permits, the old pieces of wire are uncoupled and a new center span connected. The other end's finished, and when they're both ready, the safe to land switch is made from the deck edge.
Flaps down, wheels down. Negative hook, sir.
Well, if the hook won't come down, there's only one way to get him in.
Flight deck, rig heavy barrier, 3 packs.
From their deck edge locker come the packs. Made of undrawn nylon, they'll pull out to many times their own length and absorb the aircraft's momentum. At each end of the barrier net, a group of 3 packs connected side by side. Here's the starboard group. The after end is anchored to the deck and the pack fleeted forward. With the net squared off, it's coupled to the packs. Connect the jackstay and take up the slack. With the bottom rope secured, the barrier's ready for raising.
Hooks come down, sir. Flight deck. Unrigged barrier.
A normal landing after all, but it could have been dangerous. Knowing your drill and practicing it can mean the difference between life and death for a pilot. His life is in your hands. Don't let him down.